Our next session is on the year of the International Association of Engineering Co-Founders of Deep Learning Award presentation ceremony. It is our great honor that Professor Bengio, Yoshua Bengio is the laureate of the Co-Founders of Deep Learning Award for his distinguished achievement contribution to the deep learning and also to the AI as well. The distinguished founder's speech is towards safe and responsible AI. This is a very hot topic, especially with the advance of deep learning and ChatGPT and also other technology recently, based on the achievement of Professor Bengio and also others as well. And in New York time it is morning, and in Hong Kong time it is the night time. We are very happy that our co-chair, Professor Pallet, Professor Gottlieb, and I, and also Professor Sisland, are going to represent our co-chair to share the sessions. And after the session, our colleagues will do the video recording production for the video and then have the full version to send to Professor Bengio for approval first before we release it to our ordinary member. And without further delay, Professor Pallet, can you begin your first part for introducing the remarkable achievement by Professor Bengio? Yeah.
Thank you very much, and I'm really honored to introduce Professor Yoshua Bengio. I suppose this is the right pronunciation, Bengio, and as opposed to Bengio. What I've heard, on the BBC News some days or a week ago in some news. So Professor Yoshua Bengio is a full professor at the Department of Computer Science and Operations Research at the University of Montreal and scientific director of the Montreal Institute for Learning Algorithms. Professor Bengio received his Bachelor of Science degree in Electrical Engineering and MSc in Computer Science and PhD in Computer Science from McGill University. After his PhD, Professor Bengio was a postdoctoral fellow at MIT, being supervised by Michael Jordan and at AT&T Bell Labs. Professor Bengio has been a faculty member at the University of Montreal since 1993 and heads the Montreal Institute for Learning Algorithms and is co-director of the Learning in Machines and Brains project of the Canadian Institute for Advanced Research. And I would invite the next panel member to continue the introduction of Professor Yoshua Bengio.
Okay. I will continue. Professor Bengio co-founded Element AI in 2016, a Montreal-based artificial intelligence incubator that turns AI. The company sold its operations to ServiceNow in 2020, while he serves as an advisor in ServiceNow. In 2017, Professor Bengio announced that he was joining Montreal-based legal tech startup Bottle AI as a strategy advisor. Professor Bengio currently serves as scientific and technical advisor for Recursion Pharmaceuticals and scientific advisor for Valence Discovery.
Professor Bengio is recognized worldwide as one of the leading experts in AI, and he is also most known for his pioneer work in deep learning. He is a fellow of both the Royal Society of London and Canada, Knight of the Legion of Honor of France, and Officer of the Order of Canada. Professor Bengio is the laureate of the 2018 AM Turing Award, the Nobel Prize of Computing, along with Professor Jeffrey Hinton and Professor Ian Letkin. In 2019, Professor Bengio was awarded the prestigious Cullman Prize, and in 2022, become the computer scientist with the highest H index in the world. Following concern raised by AI experts about the existential risk AI poses on humanity, in May 2023, Professor Bengio stated in an interview to BBC that he feels lost over his life's work. He raised his concern about bad actors getting hold of AI, especially as it becomes more sophisticated and powerful. Professor Bengio called the better regulation, product registration, ethical training, and involvement from government in checking and auditing AI products. Professor Bengio actively contributed to the McGill Declaration for the Responsible Development of AI. And without further delay,
the Montreal Declaration, not
because
McGill.
this is our virtual presentation ceremony, we can only present you your award certificate virtually. Yeah, this is
Thank
your
you.
there. We will arrange a co-chair to go to McGill to deliver the award certificate.
It's
and
not
also
McGill, it's Montreal.
Montreal, yeah. And in person, yeah, and also your trophy, yeah. When we they go to Canada, yeah.
Thank you.
And so, yeah, and also we are also very happy that our co-chairs are here to chair the session, including Professor Konowski. Yeah, great that you are also here. Yeah. So without further delay, let's start the speech and then the recording.
Right. So let me try to share my screen.
Yeah. I mean, you just.
Okay. Do you see that?
I was. Yeah, we can see.
Yes.
Yes.
So, yes, as you said, lately I've become quite worried about where we are going and what it could mean for society and humanity. So I'll explain those concerns and views in my speech. Let me first, bring it back to the questions that each of us can ask about our work. Is it going to be beneficial or bad, dangerous for society, for humanity? And in general, what we do as humans is we build tools, and computer science is now where a lot of those tools are being developed. The more powerful a tool is, the more beneficial it can be, but also the more dangerous it can be. So I think we've been investing a lot of money and research efforts in understanding how we can make AI systems more competent, more useful, but we haven't really been investing so much into thinking about the risks. What can go wrong? How could that happen? How can this be mitigated? And I think that's a big mistake that we need to correct as quickly as possible. Many issues have been brought forward as potential risks and harms associated with AI that touch on questions of human rights, democracy, and even the survival of humanity. For many years, I've been involved in speaking out, for example, in the Montreal Declaration for the Responsible Use of AI, speaking out about the issues of human rights, in particular, bias and discrimination that can happen with machine learning systems that imitate what they see in the data, and sometimes that is not what we really want. Another issue I've been talking a lot about is the concern that there could be power concentration. As we build more powerful tools, they can concentrate in the hands of a few players, and it's sort of a natural thing that happens when tools, for example, could be used as weapons. They tend to be concentrated in a few hands, or in the case of capitalism, you see bigger and bigger companies becoming almost monopolistic. So that sort of thing is not good for democracy. It's not good for capitalism. and we need to be concerned about it and try to find ways to reduce those effects. There's been also a lot of discussions about how AI, for example, is being used in social media already, and in other areas, for example, right now with the availability of ChatGPT. How could all this create potentially bad perturbations in our society in various ways? How could that affect the job market? Right now, it doesn't seem too scary, but what about 5 years, 10 years, 20 years from now? If we make faster progress on automation, it's going to take some time, but there's going to be a big shift in the job market. And sometimes the social perturbations might not be something we envisioned, that we understood, that we expected. For example, the polarization effect of social networks isn't something people like really had foreseen 10 or 20 years ago. But today I'll talk about more recent concerns, at least that have become more front of mind in recent years because of the advances in AI in terms of capability. And these capabilities can be used to deceive people, for example, with deep fakes, with misinformation and fraud. As well, I'll talk about how very powerful AI systems, which I call like superhuman, so they're like smarter than us on enough fronts that they could become a dangerous weapon in the wrong hands. And then finally, I'll talk about, well, not just that they're dangerous in the hands of bad actors, but that they could have their own intentions at some point, their own self-preservation goals that could mean a catastrophic loss of control, that essentially, like if we created a new species that would be smarter than us and we would not be in control of our future anymore, which doesn't sound very good. Okay, so what I mean by dangerous AI here, which is going to be the focus of my speech, is that it's powerful enough to be dangerous as a tool, much more than, say, the tools that we currently have, which also can be dangerous, of course. But also dangerous if we lose control of it, as I was saying. So, how could that happen? When could that happen? These are important questions that we need to study and prepare against that eventuality, even if some people think it's unlikely. There are a lot of people who think this could happen, and we need to better understand that because the stakes are very high. One of the ideas that has been in the center stage in the research on AI safety is the notion of alignment and AI alignment. How do we make sure that AIs behave in the ways that we intend? So the misalignment is when some entity B acts in a way that is not what some entity A intended, in spite of A having given a sort of specification of what they want B to do. And this is actually well studied in economics. It was part of one of the reasons for a recent Nobel Prize in Economics, 2016. But it's an issue with contracts. For example, if company A subcontracts some work to company B, and in the contract they say, you shall do this and that, and not this and that. In general, if you think carefully about it, a contract is never sufficiently complete. It can't possibly, have a clause for every possible setting of what B should be doing in different cases. And so it's going to leave some things out. And B may find loopholes in the contract so that they can maybe achieve their other goals, making profit in the case of companies, at the expense of A in some ways. So this misalignment problem is a real thing in economics, but it also is worrisome in AI, because in AI, what we're doing is we're contracting a machine that may be potentially smarter than us to solve problems, to do things in the world that we don't know how to do, or we can't do, but potentially the machine could. And we have to make sure that the machine is going to behave in the ways that we intend. There's, a long history of thinking along those lines, even from the Greek mythology. For example, King Midas got 3 wishes, and one of them he made was, I want to be very rich, so I would like everything I touch to become gold. And he thought that was a great idea, but it was a stupid idea, because then he couldn't eat, and he had to use the 3rd wish to undo the first 2. We've seen, those stories with the apprentice sorcerer story, which has been popularized by Disney. We've seen those stories in science fiction, like, HAL 9000 doesn't want to be turned off because it has a mission. And if it's turned off, it can't achieve its mission. And so when the human tries to turn it off, it kills the human. So this was not obviously intended by the programmers who created HAL 9000. In general, the issue is that it's very difficult to specify, say, goals, for example, that we would like an AI to follow, that perfectly match what we want. And the more powerful and more intelligent that AI is, the more that mismatch could be dangerous. The bottom line is, the decades of research in economics and over a decade of research in AI suggests that getting this alignment right is difficult, that we don't actually have a way to do it right now if the AI is autonomous and it has goals. In other words, it's acting in the world. So that's a dangerous situation. Alignment is actually an issue pretty much for all of the harms and risks that I talked about. So, for example, in the case of bias and discrimination, we want the machine to do some job, maybe to help with recognizing people who enter a building, but it may not act in the ways that we intended. For example, it may make a lot of mistakes with Black people or female, or Black females, as that has been shown experimentally. And you can see a sort of mismatch going on in all of these cases. Like, typically we don't build machines to do bad things, but they might not behave in the way that we intended. There's a kind of an interesting case of misalignment. If you think about the social contract that exists between society and companies. So society would like companies to create useful products and services, to deliver these as useful goods that can benefit people. But we don't know how to really enforce those instructions onto companies. What we have found that we can do is, in our economic system, is they're supposed to maximize their profit, but do it in a legal way, so respect all the rules and laws. The problem with that, as we all know, is that they can follow the letter of the law. So in other words, they're legal, but somehow cheat on the spirit of the law in order to maximize their profits. And there are actually examples of catastrophic outcomes of this. So think about fossil fuel companies in the previous century, who did studies of the potential danger of climate change and hid those studies and deceived everyone into thinking that fossil fuels were not a problem, and that there wouldn't be any climate problem. So that can actually be a huge issue, this mismatch, this misalignment already. And you can imagine that the more powerful an entity like a company is, the more it can deceive us, and the better it gets at finding loopholes. So now you can generalize to that notion for AI systems. Another really interesting analogy is with lobbying. So what's happening with lobbying? In that picture where, you know, society subcontracts some work to company, they specify the company's intended behavior through laws. In reinforcement learning, we have reward functions. So humans design a reward function that is basically specifying when the AI gets a reward when it's performing, you know, the intended job, and when the AI gets a negative reward when it's not acting appropriately. And that already poses problems of alignment, but it can get worse when the company can change its reward function, when it can change the laws. So it can change the laws to its advantage. And now it's not at all aligned with what was intended. So for example, with lobbying, companies can really change the laws in a way that's good for them, but not good for the people and the society's needs that were supposed to be their mission. So yeah, this could be a problem for AI. How could that happen with AI? For example, if the humans are the ones providing feedback to AI systems, like, are you doing well or not, which is currently how ChatGPT is fine-tuned, for example. At some point, the AI may find a way to get more rewards, positive rewards, but even though it's actually doing something bad. So how could that happen? Well, that's the whole point of manipulation. Yeah? You look good, but, you know, behind your back, I'm doing something. You're doing something that's not good. So humans already do that to each other, and there's no reason to think that as an AI that's smarter than us wouldn't find that, how to do that. And there's some evidence this is happening. Let's talk about the potential dangers to democracy. You know, AI is already used to influence us through advertising, and if it didn't work, they wouldn't do it. And what if these AI systems get really much smarter than us? What if they learn how to press our buttons so as to influence us in, you know, various ways that may not be good for us? That could be really dangerous in terms of destabilizing democracy by influencing elections, for example, and public opinion. One way to think about what could go wrong is that although there's already disinformation and, you know, trolls, for example, that are being paid to try to change public opinion, it could just be scaled up to, you know, in a massive way using AI. Now that we have AI systems that can manipulate language and have a dialogue with us in a way that, you know, we can't make the difference if it's a human or a machine. And in addition, if they're smarter than us, they could be even better than us at influencing us. And so, and they could take advantage of what they know about us. Like a troll human cannot get to know 1,000 different people and their specifics and how to influence that particular person, given their background. But an AI could. Now, let's go to the next level of danger, which is superhuman AI that are not just dangerous for democracy, but can act in ways that can really destabilize our society in general and potentially lead to the disempowerment of humanity and potentially the extinction of humanity. So how could that happen? I'm going to talk a lot more in the coming slides about that. First, you have to realize that your brain is a biological machine. And so there is no reason to think that we couldn't one day build machines that are at least as smart as us. And that's pretty much a consensus in neuroscience and AI, of course. Second, if we were able to understand the principles that allow us to be intelligent, and I think we've made a lot of progress in recent years, even if we completed that, because I think we're not done, we might get machines that are actually much smarter than us. So why is that? Same kind of scientific principles of intelligence, but running on digital computers. And what does that mean? It means that we can train those systems in ways that are much more efficient than us. So for example, even currently, if you look at ChatGPT, it's trained on a huge quantity of data, almost everything that is available on the internet in terms of text. And that amount of data, a human would need tens of thousands of lifetimes to read full time. But these machines can read through that and kind of compile it into the chatbot. And the reason this is possible is because you can parallelize this learning. Is because it's not one traditional computer doing the job. It's thousands or even tens of thousands of computing units that can talk to each other and exchange information at a very high rate, which is not possible for us. The way we communicate is very rate limited. We can use language, it's just a few bits per second, whereas they can exchange billions of numbers very quickly. So that essentially suggests that we will not only get to human level AI, but we'll get to superhuman AI. Now, how far into the future? Well, that's obviously something we don't know. And there's a lot of uncertainty, but the window of like plausible timelines has shifted quite a bit in the minds of many people in recent months because of the arrival of ChatGPT. So I used to think it would be decades to like a century before we reach human level AI. And now I think it may be a few years to a couple of decades. So like say 5 to 20 years. And my co-recipient colleagues of the Turing Award, Jeff Hinton and Yann Lequin, actually think the same. So we agree that it may be coming quickly. Maybe it's still going to be a couple of decades, but maybe it's going to be in the next few years. And if it is coming in the next few years, we should worry, because I don't think we are ready to deal with that power, such powerful tools, and what can go wrong with that. Part of the worry is also that the tool itself is much easier to access than something like nuclear material, which is very difficult to get your hands on and can be lethal and so on. So there are several scenarios by which someone on Earth will intentionally or not create a dangerous superhuman AI. So even if we know how to create a safe AI that we wouldn't lose control of, there are several scenarios in which somebody decides to not follow those rules, maybe for commercial reasons or because they have sort of genocidal desires. There are lots of crazy people. There are conspiracy theorists, or somebody who thinks they're smart and they're cool and they want to make the machine at their image, like a human, that the machine would have its own intentions and self-preservation goals. And that's very dangerous because it's like creating a new species that would be smarter than us. And when that happens, I think all bets are off. We lose control over our future. It's not, initially those machines will depend on us because we are there to repair the power lines. But it might be temporary, and at some point they might not need us. So there's a lot of debates about all this in the AI community, and people disagree. But there are enough people who worry that I think we should really think a lot more about these dangers. And it's not just about the AI question, like how do we make a safe AI or something, and alignment problem to be solved, but also like it's a social one and a political question. How do we make sure that as many people as possible abide by whatever guidelines for safety that we come up with? And that's not going to be easy. There will be some organizations, maybe some military organizations, some conspiracy theory proponents, some terrorists who will not follow those guidelines. And we need to prepare for that as well. In the last few weeks and months, I got a lot of pushback for speaking out about those risks. And I got sort of many people telling me things, questions or comments saying, don't worry, Yoshua, there's no problem. And, here's why. I've collected all of these things in a blog post, which you can find on my webpage. And here's a sample. So, for example, my friend Yann McCann said things like, "Oh, Yoshua, don't worry. Humanity has always benefited from technology." Well, first of all, it's not completely true, and at least some people have suffered. But more importantly, we don't have any experience of technology that's smarter than us, and that can even improve itself. Because if it's smarter than us in many ways, it can be like our AI researchers and find better algorithms. And although we don't have that experience of technology that has intentions and is smarter than us, we have experience. We've seen, biological evolution with a lot of extinctions, and in fact, we have driven to extinction almost 1,000 species or more in the last few 100 years. Another comment I get is, "Oh, Yoshua, don't worry. Humans will design those AI systems so they can control them." Well, as I said earlier, actually, a lot of the research in reinforcement learning and AI safety and economics suggests that it's not so easy to do that. We don't know. It's still an open problem. And so we should really work hard and invest much more in these safety questions. Another comment I get is, "Oh, don't worry, Yoshua. If it's not safe, we'll not build it." Well, yeah, maybe you will not build it because you're a good person, but there will be someone on Earth who will not be as ethical or as understanding of the dangers. So that doesn't reassure me. Another comment is, "Oh, Yoshua, don't worry. Computers only work in the virtual world. How could they be dangerous in the real physical world?" Well, there's actually lots of scenarios that have been discussed that could really turn bad. So first of all, our society is heavily digitized. So if you have access to the internet, and that's already the case with these systems that we currently have, an AI system can use humans to do stuff in the real world. They can, you could pay people for doing things in like Mechanical Turk, for example. You can pay organized crime for doing things that are illegal, and you can influence people. So as I said earlier, there's an issue that AI systems of the future, maybe not so far future, could learn to influence us, to manipulate us, to make us do things that we would not have thought to be good for us. And once they do that, they can also build bodies, so robots. They can make us build those robots, and then those robots can be their arms, and they don't need us anymore. They can also do a lot of damage purely from a cybersecurity point of view. Our current society is not very resilient to perturbations, major perturbations. Think about how, what happened with the pandemic. Imagine it would be much worse, and the whole, the whole economy crumbles, or our communications crumble. I mean, we are very vulnerable right now to these kinds of attacks, and there are cyber defenses. Major countries all have their experts trying to defend us against each other, but they have all been designed to defend against humans. Human programmer or a small team of programmers designing very carefully, a virus, a computer virus. But our defenses have not been designed to defend against AI programmers that would be smarter than us and could create thousands of viruses in parallel that work together. It's just completely out of scope of what we can deal with right now. Finally, another comment I want to mention, because I think it's interestingly pointing to the right direction, is, "Oh, Yoshua, don't worry. Don't worry about rogue AIs, because we will build good AIs. The good guys like us will build AIs that can defend us, and they will be safe. Well, that certainly we want to do that, but for that to happen, we need a lot more investments. For example, we haven't solved the safety problem, and we need specifically to design those AI systems so that they can be good at defending, for example, that they understand cybersecurity. And we need to make sure it happens in a way that it's not easy for, say, bad actors to get their handle on this, which means we need policies to help reduce the risks that what we are building actually turns against us. So this is not simple, and we should worry, and we should be proactive. So to summarize, there are two kinds of scenarios that could be dangerous. So the really easy to understand scenario is, think of the AI as a tool, and it's just very powerful, and it can do things on the internet maybe that could be very damaging. So think cybersecurity, think bioweapons, creating a new biological virus, not a computer virus, that could be killing a lot of people. So that's one scenario. Then there are all the scenarios associated with loss of control, where we end up with a new species that is immortal because the computers can copy themselves into other computers. We can't do that. If your body is sick, well, you can't copy your brain somewhere else, right? At least not yet. And so we are facing a new species that has a lot of advantages against us. How that's going to turn out is really hard to say, but clearly we don't want to get there. So how could that loss of control happen? So this one scenario is that I mentioned is what I call the Frankenstein scenario, or we are attracted to the idea of building computers at our image, like us. And that means there could be people who are stupid enough to give to those AI a goal of self-preservation that would be strong enough that they would rather harm us than die. I mean, be turned off, right? So that would do it. And 8 billion people, somebody's going to do it if they can. The other path is the issue of convergent goals, which is more complicated to understand, but a lot of research has been done in AI safety and AI alignment about this. And in summary, what it says is that these self-preservation goals can emerge from other goals. If you think about it, almost any goal you want to achieve, it's like in the HAL 9000. Like HAL 9000 had a military mission, and in order to achieve that goal, well, you want to preserve yourself so you can do it. But now you've introduced this intermediate goal, this sub goal of self-preservation. So this is a scenario that's been also studied, but is a bit hard to understand. Yeah, let me move on. There's another kind of perspective to understand the danger we are in. It's the evolutionary perspective. So how does biological evolution work, essentially? You've got a lot of small random changes happening in parallel to different organisms. And the changes that work better in the current ecological context get reproduced exponentially fast. So you get amplification of the best solutions. So there's a very strong evolutionary pressure to discover better solutions. To what? To survival and reproduction, because reproduction is that amplification of good solutions. But those same forces are already at play to bring about AI systems that have that are smarter and they are autonomous. So they have a self-preservation goal, so they don't disappear easily, and they want to reproduce themselves to avoid being turned off and disappearing. So the same forces that give rise to the evolution of intelligence in biology because of all the organizations, the labs, the hackers around the world that are randomly trying things, and sometimes even better than randomly, they make designed choices, that all of these things is already happening, and it's going to continue. It's not going to be easy to stop that. So this is going to give rise to more powerful AIs naturally, and in particular to AI that resist our attempts to stop their, copying themselves and turn them off. So that sounds pretty scary, but it's a pretty powerful argument. One thing I've done with a lot of crowds who don't see how these scenarios can happen is to break down the events that could lead to such catastrophes into a smaller number of steps. So I'm gonna ask questions, and you should try to answer those questions. And if and then we can combine the answers together. So the first question is when is it that we're gonna get an AGI, that we're gonna get a superhuman AI? And the definition is not easy, but I mentioned the definition of it's dangerous, meaning it has enough skills that are stronger than us that it could be dangerous to us. So when could that happen? Is it a few years? Is it a decade? Is it 20, 50, 100, 200 years? Obviously, we don't know, but you can make guesses, and you can even have a distribution of durations. But a concrete question I've asked people is, what's the probability that it's going to happen in the next decade? Because that's pretty short, but it's also quite plausible according to a lot of experts. So it looks like this first point we can, it's probably a high probability. I mean, not negligible, something like 50% or 20%. Second question, assuming there is a superhuman AI and that the recipe for building it, the algorithm, maybe the code, maybe even the weights are available publicly, which is currently how things are going if we don't have any new regulation. What's the probability that in those conditions, someone on Earth will instruct such an AI, which might be even done in natural language potentially, as we do right now with ChatGPT, to achieve something that would be catastrophic if the AI was able to achieve those goals? So it doesn't say that the AI has enough power to do it or that we can't defend, but it's about a person or an organization instructing an AI now that the AI, superhuman AI exists, to do something that would be very bad. And again, most people will say, oh, this probability is very high. Okay, so then I'm going to skip this one. What about, is it actually going to be harmful? Is it going to create very, very bad outcomes? Whether it's extinction or not, if it destroys our civilization or it leads to the death of billions of people, we don't want to go there. And that's where the question about, how do they act in the world comes up. And also the question of, can we develop the right defenses to prevent these rogue AIs from creating a huge harm? And so the question is, what's the probability that we can defend or that we don't defend if we don't start right now preparing for this and building those defenses and making sure that we reduce the potential reach of such AI systems. And if we don't do anything and it comes in the next decade, the probability that we can defend isn't that great. So if you multiply these probabilities, you end up with something that's not small enough to be reassured, something like 20% that something really bad happens. Even if it was 0.1%, I would consider that this is an unacceptable risk. The stakes are so high. Even if it's a fairly low probability, we need to kind of think about it And also those probabilities themselves are uncertain. So what if it's more probable than we thought, right? So we need to study this. We can't just be in denial that there is a potential danger. We need to be humble and say, well, we don't know. And there is a potential danger of a huge scale. It needs our attention. Now, you might be already discouraged by everything I've said, but this is about the future. And currently, we are still in control. There's still a way for humans to do the right investments in socio-technical research. So there's an AI aspect, research, a technical aspect, and there's also like a social and political aspect to all this in order to reduce potential for major harm. All right. Now, I want to use a little bit of time left to talk about one strategy that I've been working on and kind of talking about how to build an AI system that would still be very useful to us, that could give us amazing services, but would be completely safe, I think. So the idea, the base of the idea is actually an old one. It's the idea that instead of building an autonomous agent, which is sometimes people think intelligent means you can do things in the world. You have an agency. You have agency, but let's like separate intelligence from the ability to act in the world. So the part that excludes actions is really about understanding and being able to answer questions and make predictions. So how could we build a machine that understands things in the world better than us and can then help us answer questions, for example, in medicine or in dealing with climate change or in education or whatever? So the way that I think is right to do this is to break down this AI system into two components. One is what I call an understanding machine, and the other is a inference machine or a question answering machine. So the understanding machine corresponds to a Bayesian posterior probability distribution over theories that explain the data, that explain the world, given all the data that has been fed to the machine. So given all that data, what are the theories that explain it? Just so you can see, this is pretty close to what scientists are doing, except it's Bayesian, meaning it can entertain multiple theories and give different probabilities to each theory. So that's the understanding machine that we should build. But having those theories doesn't help us directly. Maybe our scientists can turn those theories into something useful, but we can also train another machine that is just trying to be consistent with those theories, with the set of all these theories, and is answering questions. So it's X be the question and Y the answer. D is the data set. So what we want really is a machine that, given the data set and a question, produces an answer. By the way, doing this in the Bayesian way is quite important to avoid one of the main issues with current large language models, which is they will be sometimes, too often, saying things that are wrong with high confidence. And it all has to do with the fact that they're trained in the maximum likelihood way, meaning they find one theory that explains the data they've been trained on, but that theory may be wrong. And because there could be many other theories that also explain the data, and they don't consider these other theories. And if you do, then you would not be so confident about these wrong answers the way that ChatGPT is. So the nice thing with such an approach is that there is no risk of loss of control, because the AI system doesn't act in the world. It only proposes theories and answers to questions, but it doesn't have any agency. So it doesn't have any goals. It doesn't have any intentions. Its training objective is purely about understanding the world and being able to answer questions about it. So I call this the AI scientist because it's like a pure scientist, but of course it's an AI. But it doesn't solve completely the problem, even if we can build that, which we don't know how to do right now, but I think there are reasonable path to that. It's not sufficient, because if we can build such an AI scientist, it can be turned into a rogue AI by writing a little bit of extra code around it that make it an agent. For example, you can ask the questions, what should I do in order to achieve this goal? And then you got an agent, and you can give it goals, and it can create sub goals and so on. So it's not enough to have the science. We also need to solve the political questions. Yeah, maybe I'm going to skip this, so as I leave a bit of time for questions. Let me just go slightly more technical to explain how these machines could be built. So there are two components, as I said. So the understanding machine wants to sample theories theta given the data D, and the inference machine, produces answers Y given questions X and the data D. So the Bayesian theory generation machine can be a neural net that samples theories, that generates theories. So we've made a lot of progress in generative AI systems that we could apply here. The question is, how do we train it so that those theories are sampled from the right distribution? And the right distribution is this Bayesian posterior, which is proportional to the prior over theories, which is something that's very simple. Like, we want simpler theories and that require a few bits, times the likelihood. So the likelihood is, given a theory, how well does the data conform to the theory? And that's something we can compute. So it's quite computable, this right-hand side. The problem is we don't know how to turn that into a distribution that we can sample from. And so kind of maybe explain how we can do that. The second problem is the training the inference machine. And again, it looks like there's an intractable computation that's needed. The equation here, the second equation, shows what needs to be done. Basically, you want to average the answers over all the theories, weighted by the Bayesian posterior over theories. And so we would need to first solve the problem of the understanding machine, which is a kind of world model. But then we would still have an intractable problem to solve. So it looks like a hard problem. The good news is we've made some progress in my group with something called GFlow nets for generative flow networks, that may be opening a path to solve those problems. And we've already done it on a small scale. So the idea is that these GFlow nets are like reinforcement learning agents, except that instead of maximizing reward, they learn a generative policy that samples objects like theories with a probability proportional to the reward. If you take the reward to be the prior times the likelihood that I talked about, which these are quantities you can compute, then the neural net will generate theories according to the correct posterior if you train it long enough with a large enough neural net and so on. So in theory, at least we kind of know the recipe for doing this. It needs to be scaled up. We can make our AI scientists safer by using the AI scientist itself as a wrapper around the question. So we don't answer questions that may be dangerous. So we can ask another question before we answer the question to the human. We ask the AI scientist, if I give this answer, could that be harmful? Like, could be used to kill people or whatever. So that might be a way to make it even safer. Also, we can derive specialized AI systems that are not dangerous from an AI scientist. So we can train it on a limited domain, like medical diagnostic, or we can turn a generic world model into a specialized question answering machine that only knows about, say, medical diagnostics. And these very specialized AIs don't understand us fully. They don't understand how society works and those, so they can't really easily take over. All right, so a big part of my message is we need regulation. We need AI regulation, and it needs to be also international, because that AI can be happening anywhere in the world. We need regulatory bodies that are going to be flexible, that can adapt to the changes in the technology and the nefarious uses that we're not thinking about right now. And we need to do it quickly because potentially the abilities of these systems can get stronger and stronger faster than we expected, as we've seen in the last few years. We are already regulating a lot of important areas where safety matters, planes, drugs, foods. Why don't we do it for AI? I think it's reasonable. And of course, there will be pushback. A lot of companies don't want any kind of regulation, but I think we have to protect the public, and we can come up with rules that are not crazy. The basic rule is we want companies or organizations building those systems to do it safely, to document what they're doing, to allow independent audits, to make sure that they perform the right tests, to check for potential harms, all of those that are associated with AI. Red teaming to try to find the potential scenarios where it can go wrong, and so on. We need to do things to protect democracy with the deployment of these systems. For example, ban the imitation of humans, counterfeiting of humans, passing for a human. We want to make sure users know on the web if they're interacting with a real other human or a machine, if the content they're seeing is genuine or it's machine generated. We want to make sure that social media accounts are associated with a real person, and real in-person registration happens, so we know that there is a person. We know who that person is that has a social media account. We don't need to have very harsh regulation for all kinds of AI, only for those that are most dangerous, like the very generalist AI. And we also want to do like we do, for example, for like airplane drivers. Like we want to make sure these people have the right training, the right ethical training, not just the technical training, and so on. So yeah, I'm gonna finish here. But what I want to leave you with is that I think in engineering and computer science, we don't ask ourselves the big questions of like, why do we do what we do often enough? What could be the consequences of what we do? What could go wrong? What can I do to bring more good into the world and not bring bad things? So this is really important, and these are hard questions, but we have to continuously ask those questions. So thank you for your attention. I'll be happy to answer your questions.
It is our great honor, and yeah, just feel free to answer question or any comment. Yeah,
I have two questions. The first one is very simple. How should we pronounce better your name, Bengio or Bengio? Because I've heard it in the two versions,
Bengio.
But what's the right way?
Bengio.
Bengio. Okay, so I was right. Yes,
Yes.
I've heard it. I should tell the BBC off then. They called you Bengio. Yeah. So the second one. I've heard Geoffrey Hinton as well worried about the machines being more intelligent than us, and but if we talk about being more intelligent, or smarter than us, we should have a pretty good definition of intelligence, or of a human.
No, it's going to happen whether we have a good definition or not. That's the problem. But
my question is, how would you define intelligence, human or artificial, for a system to be intelligent? Or
yes.
Human or artificial?
So my definition is kind of related to the things I talked about. There are two parts to intelligence. There's understanding, and then taking good decisions. So answering the questions right. Understanding is sort of harder to quantify mathematically, but in probabilistic machine learning, we can actually quantify that. It's how well do you approximate this Bayesian posteriors? And there can be multiple metrics, but basically, how good are you able to find an explanation for things that you see? That's understanding. And then the inference part is something more concrete, which is the typical way that we measure capability in machine learning. We ask a bunch of questions and for which we know the answer, and we check how well the machine does, right, at answering those questions. So this is already what we're doing. And of course, we're doing it for specific domains, but that's the, what else can we do is basically intelligence ends up about taking good decisions. And some of those decisions are, you know, something like predictions or actions in the world, but it could also be decisions about what is the right explanation, the right interpretation for things.
Mm-hmm. Okay, I would allow someone else to ask the question. Thank you. But just to continue, if we were to 30 years ago,
yes,
yeah, we didn't have much of internet. Wikipedia was not available. If I ask Wikipedia now, you know, if someone would have said now 30 years ago, I mean, it would have been a dream. If you type the name Yoshua Bengio, I'll have all the data about you. Anything I ask, I can have it, right? Yeah. Does it mean Wikipedia is more intelligent than us? It's answering questions.
No.
Very
no.
well to my. Yeah, no.
No. You can't ask Wikipedia to solve a puzzle. You can't ask Wikipedia to translate something new. You can't ask Wikipedia to draw a new painting of Picasso. There are many ways in which Wikipedia is lacking. Wikipedia doesn't compute. It's only a repository of knowledge. So for example, it cannot reason about these pieces of knowledge to answer new questions, which is what these neural nets are doing. I mean, it's imperfect what they're doing. They're still making mistakes, but they're really impressive in their abilities right now. What are they doing, right? They take the data that they were trained on, which is like Wikipedia, but it's not very well organized. And they extract information from it that allows to answer new questions. Basically, they piece the information that's needed together in order to come up with answers. And, you know, they get the answers right enough to pass the, you know, the bar exam or something. And they can manipulate language well enough to fool most people in a, 10-minute dialogue. So whether they understand the same way as us, no, they don't. But they've done quite a bit of understanding, and they do have quite a bit of intelligence. They're still missing some important ingredients. So this is something I haven't been talking about in this talk, but in the last few years, most of my talks were about this. So what is missing from ChatGPT? It's missing what I and others call system 2 capabilities, which is everything having to do with your conscious processing. So that includes things like your ability to reason in a very coherent way. That includes things like having a good sense that some statement is true or not with some degree of confidence and not getting it completely wrong. That includes things like understanding causality and being able to discover new abstractions, new causal explanations, for example. So all of these abilities in humans are associated with our working memory. So this is the bottleneck where your thoughts go through. It's like a small pipe, a few bits of information per second. That's also where language kind of emerges from. And that's where you think. There's a process going on in your brain that's now becoming better and better understood by neuroscientists and cognitive scientists that we currently don't have in AI systems. But there's been a lot of work about this in machine learning in the last few years. And it could be that in the next few years, we can actually get that into computers, but we don't know.
Mm-hmm. Okay, thank you.
Yeah, thank you. If no more question, thanks our work earlier. Professor Joseph, thank you a lot. Yeah, I will email you when we have the proof version of this video. With your approval, then we will release it to our member. Okay, thanks a lot.
All right. My pleasure.
Okay.
Thank
you, everyone.
Bye.
Bye. Bye.